Hello, everyone. Today, our group is going to be talking about generic algorithms. My name is Kaliel Vieira, and I will start the topic talking about what is a generic algorithm. A generic algorithm is a search-based algorithm based on the theory of natural evolution. In the process, tries to find the most optimal solution to a problem where it can vary from finding hardware bugs to simulating biological evolution in an environment. The algorithm consists of 5 phases, which are initializing population, fitness function, selection, reproduction, and mutation. Finally, the three main operators of the process are reproduction, crossover, and mutation, where the main idea relies on improving future generations.
Hey, I'm Zachary Hutcherson, and I'll be talking about how genetic algorithms work. A genetic algorithm begins operation with an input population of individuals. A fitness program will be applied to determine the acceptability of the population. If the population passes, we can continue to the next step. We then will select the best individuals to become parents to the next generation. From those parents, we will cross over specific sections of code to the new population. Certain individuals from this new population will undergo mutation where random pieces of their information will be altered. These processes will then repeat with this new population.
Hi, I'm Jason Doyle, and I'll be doing a brief overview of some of the math behind genetic algorithms as it applies here. So genetic algorithms are an optimization problem similar to most curve fitting or slope following algorithms. But because genetic algorithms only focus on the fitness function at discrete points rather than trying to follow the slope, where by triangulating the various values it has, it can kind of find values with greater fitness values, hopefully. Because of this, genetic algorithms are more of a meta heuristic, and through this they can still get stuck at local maxima, but it's possible for mutate to get out, and they can work on non-smooth functions and functions with very discrete values. However, at the same time, genetic algorithms will still solve linear problems in O of n log n time, as Strost's paper describes.
Hey, I'm Abhinish Khatka, and I'll be talking about what a genetic algorithm could look like. So genetic algorithms are used for a variety of things. They range from being used for file allocation to image processing to simulating evolution, but most have a similar structure and functions since they use biologically inspired operators, some of which shown in the images below. On the left, you can see an example of a simulation of evolution. You can see the different generations and how it aims to optimize the figure. To the right shows the biologically inspired operators and structure that most, but not all, genetic algorithms follow.
I'm Jason, I'll be back again, just doing a bit of stuff about how can we use genetic algorithms. Genetic algorithms, the best case is when you have a starting population of algorithms that you can convert to the 1 and 0 bit strings that the genetic algorithm will actually apply to already to start. So from these algorithms, the most fit will be the most fit will be used, and from them you will ideally generate a much more efficient algorithm through a process of mutation, where you will kind of take this set of possible solutions and refine them and triangulate them towards the best one. Robert Axelrod from the University of Michigan used dozens of algorithms for the prisoner's lemma through this process to generate a much more efficient algorithm. Another use case of genetic algorithms is with improving neural networks, forming recurrent neural networks, which is a different type of neural network, which can be used for different sort of problems, because with this feedback net, you can better figure out where you want to go and avoid local maxima that you don't want to be at, and so on. Counterterrorism is one use case for these recurrent neural networks.
To conclude our topic about generic, we can affirm that it is based on Darwin's theory of natural evolution and selects the fittest to improve future generations. And as already mentioned, it can be applied in different circumstances. For example, it can be used in a file allocating systems, but it can also be used to simulate biological evolution in the environment. Finally, the generic algorithms usually perform better than traditional techniques because it does not focus on a single point, so it avoids being trapped in a local optimal solution.